Hey guys, Mr. Smith here, and I'm shooting a video doing a couple examples of a neat application of solving by factoring. I call these kind of problems border problems. And so in this video, I'll be doing a couple border problems with you guys. I'll talk about what I expect from the 3M students versus the 3U students. And I think I'll also post this tonight, Monday, and send an email out to you guys saying if you want to check out this video before even going to class. This might get you a bit of a head start. Okay, but yeah, let's jump in. So here's the first problem we're going to be looking at, and here's the situation. So in this fictional problem, I'm buying an area rug for my living room. Now we do have a living room, we do have an area rug, but my living room is not 12 feet by 10 feet. But in this question, we're saying my living room is 12 feet by 10 feet. And maybe just we can say off to the side here that 12 times 10, that would be 120 square feet. That's the area of my living room. Now, not any old area rug will do. Mrs. Smith has some very specific instructions. The rug must have a uniform border around the outside of the room. So what that means is the distance from the rug to that wall, into that wall, into this wall, and to this wall, it has to be the same distance, giving a uniform border around the room. Could be 1 foot, could be 1.5 feet, could be 1.2 feet. Second thing, because there's a lot of rugs that will do that, some will leave a big border, some will leave a small border, is that the area of the rug, for whatever reason, should be about 2/3 the area of the whole room. So just really quickly, 2/3 of 120, the area of the living room. So 1/3 of 120 is 40. That's 2/3 would be 80. The area of the rug itself must be 80 square feet. So how can we go about a way of setting up an equation that will help us solve this problem? So the key idea, and I'll type this in, for any border problem, we're going to start with the following. We're going to let x, a new variable, represent the width of the, I'm just going to make it bold here, of the uniform border around the room. And I'll just label that on my diagram. So a little x here, a little x here, a little x here, a little x here. All right. So essentially we're trying to find, okay, what border, 1 feet, 2 feet, 1.5 feet, will give us that area rug having a area of 80 square feet. So let me show you guys how we can set up an equation that models this scenario. So of course, the entire living room is 12 feet. What we're going to do now is we're going to come up with an expression for just I'm going to dash a couple lines down here. Just an expression for the length of the area. We don't exactly know how big it should be yet, but however big it is, it's going to be 12 feet, right? 12 feet is the length of the entire room. But then on either side of that rug, we're going to have that border. So 12 minus 2 of those uniform border widths, right? It's the whole room minus one border minus another. And that's an expression for one dimension of our area rug. For the second one, maybe I'll do just down here like this and add a couple dashed lines. In a similar way, the entire room was 10 feet. So how about the rug? Well, the rug will be 10 feet minus 2 of these borders. Okay, so 2 borders, we subtract 2x. How does that help us? Well, let's go to an equation for the area of the rug. So we know that area of a rectangle is length times width. Well, we know the area of the rug, it needs to be 80 square feet. We have an expression for the length of the rug, 12 minus 2x. And we have an expression for the width of the rug? 10 minus 2x. We now have an equation here that we can solve for x using our skills from yesterday. So I'm going to walk through this one and solve it with you. And if you need to pause, you pause and restart and rewind and do that as much as you need to. But right now, we can't just set these factors to 0 because these factors multiply to 80. To set them equal to 0, they need to multiply to 0. We have some work to do. First, we have to expand and simplify and collect all these like terms on one side of the equation. So we have 0 on one side. And I'll show a few steps here. And when you're doing it on your own, you can skip a few if you're comfortable. But 12 times 10 is 120. 12 times negative 2, negative 24x. Negative 2 times 10, minus 20x. Minus 2x times minus 2x, positive 2x squared. Then we'll collect like terms. And I think I'll even, at this point, move the 80 over as well. So what do we have? We have 2x squared minus 24 and minus 20 make, oh, you know what? You're probably raising your eyebrows. That should be 4x squared. I'm glad I caught that. I would have caught it later. 4x squared, excuse me. Minus 24 minus 20 is minus 44x. And then we're going to have 120 subtract 80 plus 40. Now it's in a form where you guys can use yesterday's methods to solve this equation by factoring. Now, before you reach for the Australian method, remember that it's often helpful to common factor first. So we can divide a 4 out of all these terms. And what we have left is a simple trinomial. I didn't divide it. I'm doing this at the end of the day, so please forgive me. That should be minus 11x plus 10. If I were a betting man, I would say that this is not the last mistake I'm going to make today. So it adds negative 11 and multiplies to 10. Those two numbers are negative 1 and negative 10. This is going to give us two possible solutions. What makes x minus 1 equal to 0? X equals 1. Remember, x is the length of the uniform border, so that's 1 foot. Border is one possible answer. And then x minus 10 is equal to 0, which means x equals to 10 feet, a 10-foot border. So we're almost done. Note we got two possible positive measurements here, but only one of those makes sense. Remember, the room is only 10 feet by 12 feet. So it's physically impossible to have a rug that would have a border that's 10 feet. I'm just going to add, I'm just going to put a little X through that. I'm just going to write in not possible for the reasons we just discussed. And so the uniform border width is 1 foot. So the border is 1 foot. And if we think about what the question asks for, what size should the rug be? So the rug should be, so on one side of the room, or one side of the rug, we have 12, and then we're subtracting 2 of those border widths, which we just found out was 1. That means the rug should be 10 feet long. Should be. And on the other side, 10 minus 2 times 1, 80 feet wide. 80 feet wide, 10 minus 2, 8. 8 feet wide. And we found the ideal rug for Mrs. Smith. It has the right area to look nice, but it makes that uniform border around the room. Okay. Now, what are my expectations for the 3M students versus the 3U students? So the 3U students, what I would expect is that if I gave you this setup and maybe even a diagram, that you could take it from there. Let X be the width of the uniform border, and you could create your own equation using area equals length times width. For the 3M people, I would expect if I gave you the equation that you could explain where it came from, but the 3M people, I would expect just have the equation and keep solving. So 3U people, for this next example, you may want to try setting this up on your own. You may even want to try doing the whole thing on your own. 3M people too, but for the 3M people, you may want to just follow along till we set up the problem and then take it from there. But I would definitely encourage you to try setting it up on your own. So feel free to pause the video and try this, or pause and unpause, or I'm going to actually at this point just do the problem. So you're warned, spoiler alert, here we go. This time we're in my backyard. We're putting a uniform walkway in the backyard. My backyard is 15 by 12 meters, so it might be just worthwhile. 15 by 12 is 180. Not sure if we'll need that later, but just a helpful aside. This time, Mrs. Smith says there must be exactly 108 meters squared of grass left over. Who knows, maybe that's the amount of seed she has. Maybe, for any bigger lawn, the lawn care company that we don't use anyway, but the lawn care company might charge more. I don't know. But for whatever reason, the area must be exactly 108 meters squared for the grass. And we've got the backyard is 15 meters there, I'll put, and 12 meters there. And I don't think it's a bad idea to just show the uniform border all the way around and label it. Okay, we're ready to start this problem. The starting point is always, we're going to let X represent the width of the uniform border. Okay, from there, we're going to create an equation. To do that, we need an expression for the length and width of the grass. So, just like we did before, this side of the lawn is 12 meters, but we're taking off a border on either side, 12 minus 2x. On this side of the lawn, the entire backyard is 15 meters, and we are taking 2 border widths away from each side. So a border on each side, subtract 2x. And that allows us to create an equation like before, because the area of the lawn, of the grass, length times width, the area has to be 108. The length, 15 minus 2x. I always do length as long side, but it doesn't matter really. And the width, 12 minus 2x. All right, so we have a quadratic equation that we can solve and hopefully get the width of the uniform border, which is actually just what this question wants. Then we can stop. So to be clear, 3U people, I'm going to have you guys set up one of these on your own and make your own equation. 3M people, you'll have the equation. You'll have to be able to explain where it comes from. Now we just have to solve this equation. It's a very similar process to what we just did. So again, feel free to pause and unpause. Excuse me. 15 times 12 is 180. 15 times minus 2, minus 30x. Minus 2 times 12 is minus 24x. And plus 4x squared. All right, let's calculate terms. So we have a 4x squared. All right, so minus 30 subtract 24 is minus 54x. And then 180 minus 108 is equal to 72, plus 72. All right, we have some work to do. We need to factor this. This might be the largest numbers that we've had to do together trying to factor something. But we can do a little bit to make our life easier here. I know I can at least divide a 2 out of everything to make the number smaller. But notice when I divide a 2 out, I'm still left with 2x squared. I'll still need the Australian method. Minus 27x plus 36. Okay, so we need to find two numbers that add to minus 27. Multiply to not 36, but 2 times 36. So multiply to 72. And at this point, maybe you want to pause the video and figure that out. So we have a 2, and then we're factoring this complex trinomial using the Australian method. So 2x, a 2x, and a 2 down under. Now notice in this case, the 2's will divide out. That's pretty cool. So if we find the 2 numbers, we'll be done. Now I know that because we multiplied a positive 72 and add the negative 27, both our numbers will be negative. So if you guys, with the people around you, can just brainstorm numbers that do that, you can pop those in. But I know that they're 3 and 24. And as we saw yesterday, cool thing about the Australian method and solving by factoring is we can just actually go right to setting our brackets equal to 0. So 2x minus 3 is equal to 0. 2x minus 24 equals to 0. So that gives us 2x equals 3, and that gives us x equals 3 over 2. 3 over 2 is 1.5. 1.5 meters should be equal 0. So 2x equals 24, and we get x equals 12 meters. One of these doesn't make sense. 12 meters wouldn't make sense for a backyard that's only 12 meters by 15 meters. So this one is not possible. And so we are done. Our border width is 1.5 meters. The border should be 1.5 meters wide. All right. Now, I think it's worth doing a quick check here. So 1.5 on either side means you're taking 3 away from the width and 3 away from the length. 15 minus 3 is 12. 12 minus 3 is 9. And you can double check for yourself. That 12 times 9 is 108. And we did it correctly. All right, guys, one last time. 3U people, you're going to have to set one of these up. 3M people, I expect you to solve this level of equation if it was provided to you, but I would also ask where the equation came from. All right, so how do we do? Timing-wise, 17:40, under 20 minutes, not too bad. That should leave you guys with 50-ish minutes to do a good job on this short assignment I have for you guys. And if you don't finish it in class, please finish it for homework tonight and get it to me the next day. All right, guys, take care. We'll see you soon.